Hello, Kristen Knutson, production manager and technical director at the College Light Opera Company, coming to you from the Highfield Theater. Behind the Scenes with Kristen Knutson is made possible by a generous gift from Clyde Tyndale and Deb Winograd. So far, we've explored the history of the Highfield Theater and the West Falmouth Inn, and now it's time to get a little more hands-on. I'm going to start with an extremely abridged history of theatrical scenery, give you a quick overview of the most basic building blocks that make up the worlds you see on stage, and then we will return to the scene shop at Highfield so I can demonstrate construction of a parallel frame, which I'll explain more about later. Let's rewind to ancient times, shall we? I would like to preface this by acknowledging that the scenic trends that led to your favorite Broadway and opera sets come from extremely Eurocentric origins. Every culture has its own theatrical traditions, so please keep in mind that this description is by no means all-encompassing. During the Greek, Roman, medieval, and Elizabethan periods, the rear wall of the theater was the scenery. Occasionally, especially during the medieval morality plays, scenic elements such as the Hell's Mouth were introduced. Generally, the scene's location was either obvious, unimportant, or stated in a character's lines. The latter was the standard practice during the Elizabethan era. Scenery as we know it today is a product of the Italian Renaissance. To a large extent, it is based on the discovery of the rules of perspective and their application to the world of architecture. In the early 1500s, artists began experimenting with perspective to trick the eye of the viewer into perceiving greater depth or height in a physical space. Raked stages became common, in which the downstage end sat flat at or below eye level and had a sloped portion rising toward the upstage end. Painted flats were set on this slope, often decreasing in size the closer they were to the rear wall, to create an illusion of distance. Sets of flat or angled wings on stage right and stage left also contributed to this false horizon, additionally providing masking for the offstage areas. Italy's influence spread to England and France, where the proscenium arch emerged in the early 1600s. Scenery was elaborately painted, but still represented by flat surfaces and backdrops. If there were any scene changes, they were achieved by flying drops in and out. Fast forward 200 years. In Europe and America, realism and dimensional scenery was on the rise. The box set, with real doors, decorative molding, and furniture, provided a realistic facsimile of a building's interior. As theatrical lighting developed, there came a desire for three-dimensional objects upon which light could affect dramatic shadow play. The use of electricity, pyrotechnics, and hydraulics generated on-stage special effects to wow audiences. Scenery took a turn toward a stylized approach in the 20th century. Scenery could be sculptural, almost abstract. Classic forced perspective scenery lived on in opera and ballet, and today we often see a blending of all these styles on Broadway. In the past few decades, the rise of computer-controlled automation has led to more elaborate scene changes and moving elements, including programmed lateral movement across the stage and special effects to dazzle the eye. It's very likely that when you imagine what the set of a Broadway musical looks like, you are imagining that very spectacle. No matter the style of the scenery, you can be assured that hundreds of hours of preparation and hard work went into creating the illusion on stage. Stagecraft is the technical aspect of theatrical, film, and video production. It includes constructing and rigging scenery, hanging and focusing of lighting, design and procurement of costumes, makeup, stage management, audio engineering, and procurement of props. Considered a technical rather than an artistic field, it is primarily the practical implementation of a scenic designer's artistic vision. The scenic design must be broken down into buildable elements, taking into account any constraints of the venue or planned transportation. Of course, there's no one right way to do the job, but there are construction standards well known to all stagehands. Flats and platforms are the most basic building blocks for creating a set, and most scenic carpenters learn to construct these elements first. Flats are frequently used to build walls, architectural elements, and offstage masking. They can be framed in wood or metal, covered in a hard material or a soft fabric, and built to any size manageable by hand. It's very common to see 4-foot by 8-foot flats, simply because sheet goods like plywood and luan are readily available in those dimensions. The two styles of framing typically seen on stage are the Broadway and Hollywood flats. The Broadway, sometimes called an opera flat, has wooden framing joined on flat and braced with keystones and corner blocks, resulting in a very thin, lightweight frame upon which fabric is easily stretched. The Hollywood, sometimes called a TV flat, has framing built on edge, resulting in a thicker but more stable flat that is easy to clamp or screw to adjoining segments. To hide seams between flats, clever use of molding or strategically planned paint treatments can disguise break lines. For longer runs, sometimes seams are pasted over using a method called Dutchmaning, in which strips of fabric are smoothly applied and painted over to obscure any gaps between flats. Platforms are often constructed like very heavy-duty Hollywood flats and are used to create levels on the stage. Platforms can be constructed with wood or metal and are also frequently created in standardized 4-foot by 8-foot pieces. Often, platforms are used to elevate the entire stage deck, either for sight lines or to allow space below for automation, sound, and electrics cables and equipment. When the desired height of the deck exceeds the depth of the platform framing, it becomes necessary to build support structures that are both efficient to install and sufficiently strong to support the weight of scenery and actors. Some of the more popular support structures include individual wooden legs and bracing, short wooden or steel stud walls, steel pipe legs and bracing, and collapsible frames. Each style has its own advantages. Long stud walls are quick to build, can be set up to support multiple platforms, and their continuous nature can help smooth over uneven stage flooring. Steel pipe is quick to set up and very strong, provided it is properly braced, but inherently more expensive than wooden options. Collapsible frames are great for fast setup and tight storage, but take more time to build correctly and require more leveling effort between platforms when on an uneven surface. These collapsible frames are called parallels, and though they may be constructed in many ways, they all rely on hinges to allow quick setup and strike. In my opinion, parallels are not the most cost-effective option for one-off productions. But once you start looking at touring or repertory productions, fast setup and efficient storage can become a deciding factor. It's a lot of labor up front, but significant time savings later. They can be pretty fun to build with very little material, so I would love to invite you into the scene shop for a little tool safety and a tutorial on the construction of a 2-foot by 6-foot parallel frame. First, I'm going to give you a peek at my drafting process. Hand drafting is something of a dying art, and unfortunately, I've never been specifically trained in it. My drafting sensibilities and style have been developed after years of practice and observation of other draftspersons. I've used CAD or computer-aided drafting since about 2003. Back then, I still imagined myself becoming a scenic designer, so I took some AutoCAD drafting and computer modeling courses at the Boston Architectural College in anticipation of eventually going to grad school. I did not end up pursuing scenic design as a profession, but my AutoCAD training led me into technical theater. AutoCAD is a professional 2D and 3D drafting program that is widely used by designers, architects, engineers, you name it. When it was first developed, everything was drawn using typed commands and numerical coordinates. Today, the software is much more user-friendly with buttons and drop-down menus listing all your options. When I learned to use AutoCAD, there was still heavy emphasis on using the commands. So when I draft, I prefer to clear away everything I don't need on the screen and use command shortcuts instead of clicking on buttons. What you are seeing right now as I draft is a similar program called DraftSight that I discovered this past year. It has most of the same features as AutoCAD, recognizes most of the same commands, and it's a lot easier on your wallet. I tweaked the interface here to behave as much like AutoCAD as possible. Vectorworks is another very popular drafting program, which in the theater world is more heavily used by lighting designers and college students. As I draw, I set up non-printing reference lines that are not part of the final image. You can see them represented in red here. These are often parallel lines, offsets, and circles, all geometry that helps me align my work and stay within the desired finished dimensions of the piece. I usually delete these reference lines as I finish a drawing. I also copy, rotate, and mirror elements very frequently, particularly on symmetrical units like this. In CAD, you can put objects on different layers to help keep things organized. I personally like to create layers based on materials, but there's really no wrong way to categorize layers as long as it works for both the draftsperson and the end user of the file. Here the orange lines and shapes represent lumber, and the light blue represents hardware, in this case the placement of hinges. I nearly always begin with a plan view of the item I'm drafting. Plan view just means looking straight down at the top surface. This is the same sort of view you see in a full ground plan. Then I follow up with front and side elevations, which are the straight-on views from the front and side of the piece. This parallel unit is symmetrical, so I don't need to make separate drawings for the back or opposite side. There are times when I do draw all views, particularly when I need to specify drilling patterns for bolt holes or any atypical framing. When I'm happy with my plan and elevation views, I separate out component drawings. I want to show a very clear image of just a single wooden frame, so I'll copy that portion of the drawing and remove all the unnecessary information. These component drawings become the construction drafting I would hand off to a carpenter. In this case, the carpenter is me. When I want to print a drawing for use, I'll generate a drafting plate or a sheet that represents the size of the printer paper. Here I'm setting up a print on 8.5 by 11 office paper. I can arrange and scale my drawings on the page, add the dimensions the carpenter will need to build the piece, and add notes if desired. This is a very quick plating for my own use. If I were creating this to send to a shop, I would include a full title block, materials callouts, and assembly notes. In real time, this drafting and plating took me about 40 minutes, not including some technical difficulties at the beginning. So I am going to be using recycled lumber today. This is all 1x pine that has been ripped apart from something else that was constructed. Maybe it was platform, it looks like maybe it had some shelving attached to it. It was scenery once upon a time, and now it's going to become a parallel for a platform. But when you're using used lumber, as happens pretty frequently in theater, especially when you don't have huge budgets, you're going to have to take a really careful look at what you've got so you're not running a bunch of metal fasteners through your saw. So here I can find, here's at least one nail sticking through this board I'll have to pull out. So now I'm going to rip all this scrap lumber into 1x3, which is the nominal dimension. It's actually 2.5 inches wide. I could go into a whole story about that. When you're trying to buy lumber, you'll find that what it's labeled as is never really what it truly is. It all has to do with how the cut comes out of a log. So I'm going to do a little time lapse of me cutting up this lumber, but before I do, I want to talk a little bit about safety. When operating power tools, always wear appropriate personal protective equipment. Protect your eyes from particulates and flying debris with polycarbonate safety glasses, goggles, or face shield, which come in a variety of styles to suit your needs. This pair fits nicely over my glasses, but it is possible to get prescription lenses with safety ratings. Protect your hearing with earplugs or over-ear muffs that reduce noise 15 to 30 decibels. Noise-canceling headphones are not an appropriate substitute. Earplugs must be inserted fully in the ear and allowed to expand to fill the ear canal. Long exposure to sounds louder than 85 decibels can cause permanent hearing loss. Many common power tools generate sounds exceeding 100 decibels. I've got my eye and ear protection on, so let's start building. So I want to set this saw up to cut the 1x3. There's a release over on this side, and you may see, I don't know if you can see in the camera, but there is a ruler set along this edge, and this guide is able to slide into different positions so you can set your distance from the blade. The ruler guide's usually pretty accurate on these things, but it's not a bad idea to double check everything with the actual tape measure. So I've got it set according to the ruler at 2.5 inches, and now I'm going to check with the tape, measuring from the inside of this fence to the fence side edge of the blade teeth. I'll show in a moment. It's close up. That's pretty much perfect. So we don't need to do any angular or bevel cuts on this particular saw for this project, but it's always a good idea to double check that the blade has been left perpendicular to the surface. So you want to really kind of eyeball it and make certain that it's 90 degrees to the surface of the table. There's no angle that's been set in it by someone previous to you using it. We want to set the blade to an appropriate depth for the material we're cutting. 1 by is only 3/4 of an inch thick. So I've set the blade extra high just to illustrate what I'm doing here, but you'll always want to kind of nestle your stock right up to your blade, and you can lower that blade until you see the teeth just barely poking up above. You can see there's just the tiniest bit, maybe only 1/8 of an inch of blade coming above the surface. It doesn't hurt anything to have it taller in terms of its cutting capacity, but it's not necessary, and you're only putting your fingers at greater danger. If you have it set so it's just barely cutting through the material like this, if for some reason, heaven forbid, my hand did go over the blade on top of the wood, yeah, it would still get cut up, but it wouldn't cut fingers off as easily. So I just want to show you kind of over my shoulder here what I'm paying attention to when I'm using this tool. I've got a little scrap of plywood, which is the same thickness as the wood we're working with, so I don't have to change the blade or anything. But I just want you to be able to see what's happening here. 2.5 inches isn't too tiny. I personally am comfortable placing my hand here against the fence. If it gets much more narrow than that, people often will craft push sticks. You can also purchase push sticks. It's important to keep the material against the fence. You shouldn't be seeing any big gapping here where it's meeting. You want to keep it nice and tight. So as you're feeding material through, you're pushing forward, but you're also pushing this way, keeping it against the fence so that as it goes through the blade, you don't end up wandering off in a funny direction. You want to know where the blade is and where your fingers are. So when I'm doing this, I'm not looking all over the place. My eyes are pretty much locked right at the blade and the edge of the fence. So I'm looking at where the blade is and how this gap is looking right near the blade. If you're running a long board like you just saw me doing in the time lapse, you never want to take both hands off the material while the blade is running. You always want to kind of like let go of one hand, move it back, and grab on, because there's potential for kickback. The blade is spinning toward me, and it wants to grab the material and shoot it back toward me. All right, so let me just run this. So I brought along a copy of my very quick drafting of what we're doing. I don't really need it for building, but it's a great idea to have a copy just so I can reference it when I'm making my cut list, which is basically the list of lumber pieces I'm going to generate for myself that specify like how many pieces I need at 1'5" and how many pieces I need at 5'9". It helps you keep track of what you're doing, especially when you get into mass production and you're building many of these things. I need about 52 or 53 linear feet for this project, and I have 61-ish. So as long as I'm very careful how I cut this up, I should be good. So now all the lumber that I ripped, I'm going to cut into all of our usable pieces using the sliding compound miter saw, thus named because it slides. And the compound miter is referring to its ability to angle in 2 different directions for bevel cuts. So it can pivot back and forth like this. And it locks into certain angular dimensions, which you can lock down. And then in the back, there should be a dial I can loosen that allows this head to pivot back and forth this way as well. Usually there's a pin you can pull to make it go the other way. So I'm going to tighten this back down. And here we go. I need to cut 10 pieces at 1 foot 8 3/4, and that's enough pieces to make it worthwhile setting up a stop along this fence. The fence is not really on the ideal side for this particular saw, given that I am right-handed and the tool is also very much set up for right-handed people. But I will go ahead and set this up and then I'll show you what I've done once it's arranged. I've set this block 1 foot 8 3/4 away from the blade so that when I push the material in, it'll be gentle, because if I knock it hard, it'll move. But I can push material in and I can know pretty reliably that if I cut, even without measuring there, it's gonna be 1 foot 8 3/4. And I can do repeated cuts over and over and over, skipping the measuring portion and save some time. So one safety tip when using a stop like this with a saw, you're essentially capturing a piece of wood between two hard surfaces. You're catching it between the block and the blade. And if it wants to move, it doesn't have much of anywhere to go except for to kick upward. Thankfully, these saws cut away from you, so the blade is rotating toward me at the top and away from me at the bottom where it's contacting the wood. So it's not likely to kick the wood out at me this way, but it can jump, it can hop a little bit, and it's a little bit startling. It's best practice just to keep a very firm hand on the piece that's captured and then operate the saw with your other hand. In this case, a little awkward because it is a right-hand saw, but totally doable. My stack of 10 pieces at 1 foot 8 3/4 are destined to become the sort of outer piece of the frame that also serves as a leg where it makes contact with the floor. So you might notice at the very bottom there, I'm actually going to nip off the corners at a 45-degree angle, leaving a much smaller surface area to contact the floor. This really just helps make it easier to shim when you're putting it on a stage that may be unlevel, and it also looks kind of nice. Here I'm setting a stop by screwing a block of wood to the work surface. This will help the beveling go much quicker. Now I'm going to begin assembling the individual flat frames that make up this parallel. As I do this, I'm going to talk a bit about how I would like to do it versus how I'm going to do it based on the materials, fasteners, and tools I actually have at my disposal. On a flat frame like this, your wood glue is actually providing all the strength in the joints. We're going to be using staples as a way of sort of knitting together the pieces long enough for the glue to set up and create a very strong bond. Once it dries, oftentimes you'll find that if you try to rip apart two pieces that have been bonded with wood glue, the wood itself will start to tear before the glue will fail. Ideally, this would be done with a wide crown stapler. I could not locate one today. Doesn't mean we don't have one, but I couldn't find it for today. But that's okay because we're making a very, very lightweight piece. It's not actually going to be used to be stood upon. I think at the most it might become a bench or a low work table for me. So I'm okay with it being lighter weight fasteners. What I'm going to use today is a multi-tacker tool, which I would not recommend it for a production shop, but it's great if you're a hobbyist. It's great if you don't want to have an air compressor in your garage, but they don't usually have the strength of a pneumatic stapler or nailer. So on these units, usually because they're electric, they're not pneumatic, they're electric, there will be an on and off switch. And they still have a safety trigger, so there's a portion at the front where if it's not pressed against the wood, it won't fire. So if I press this firmly against this piece of plywood, I can pull the trigger and it shoots a staple into the wood. You can see here that the staples are crossing the seam between pieces, and they are arranged in an array of opposing angles to prevent them from shifting. One parallel unit requires 3 of these narrow frames. If we were preparing a full stage deck for a set, there might be upwards of 60 platforms requiring around 180 identical frames. In such a scenario, a carpenter might use wooden blocks to set a jig or template on their work table, eliminating repeated measurement for alignment and keeping the work consistently square. Flat frames like this need some reinforcement in the corners, which serves as bracing to keep the frame rigid. Thin plywood is often used to create keystones and corner blocks. I did not have any quarter plywood on hand, but I did find some scrap Luan, which is acceptable for this demonstration. When creating corner blocks, you want the direction of the wood grain to run parallel to the long side of the triangle. I had to cheat these corner blocks a little smaller than usual in order to make best use of my scrap Luan. The small rectangular pieces that patch across the non-corner joints are called keystones. Both keystones and corner blocks are glued in place and fastened using narrow crown staples or brads. Here, I'm using a pneumatic brad nailer, which fires small pins with a very small head. With all frames built and braced, it's time to assemble them into a 3-dimensional object using hinges. For this project, I'm using some small utility hinges, a little smaller than I originally planned for. Any back flap hinge will work as long as all hinges used in the project are the same. If you mix and match different pin sizes, your pivot points will be ever so slightly askew, and the action of the parallel won't be as smooth. Here, I'm very carefully aligning these hinges so that the gaps between frames are consistent. The center interior frame goes in at a slight angle, which allows the barrels of its hinges to be seated directly at the center of the unit. If this placement is too far off, the frame might bind when operated, or it may not collapse as tightly as intended. Now completed, this parallel frame can be used to safely support an individual platform. If I were to make a plywood lid, this would create a 2-foot by 6-foot platform at a height of 24 inches. Collapsed, the frame is under 3.5 inches thick and can be stored in narrow areas. It can be set up in a matter of seconds and is very lightweight. For transport, parallels can be secured in their collapsed position using tie line or straps of Velcro. This parallel is likely to become a low work table for me later in the summer when I build the Highfield's new orchestra pit railing. If you're interested in printable plans or a DWG of today's parallel project, check below in the comments during this episode's Facebook premiere. I'll be lurking during the show to post a link to the files and respond to any questions you may have. You're welcome to make use of my drawings, just be safe and wear your personal protective equipment. This week, construction work on campus slowly crept toward the next big step. Though I don't have any new photographs to share with you today, you can expect a big update next week as we will see simultaneous concrete pouring for the rehearsal hall slab and a first pass of paving in the driveway and parking lot. Thanks for joining me today. Behind the Scenes with Kristen Knutson is part of our larger series, Digital Clock. Digital Clock is made possible by a generous gift from Phil and Liz Gross. If you'd like to learn more about our programming or how you can become a supporter, please visit us at collegelightoperacompany.com. Join me again next week for more stagecraft demonstrations and updates on ongoing construction. Have a lovely day.